Hello. Today I am installing Keet on a headless Raspberry Pi. The purpose of this setup will be to create an always-on peer, acting as a relay, ensuring that messages broadcasted into any chat room will be available to all intended recipients as soon as they go online. But first, a warning. Keet is alpha software, and they're keeping the source code closed, with the intention of opening it up further along in its development. So use Keet for testing purposes only. And keep an eye on their website and social media for changes to their source code policy, in order to either start using Keet more liberally if they indeed open their code, or just deleting it, if they don't. Keet allows for peer-to-peer communications between clients, all running the same software, without the need of a server, and without any additional network configuration. The downside to this kind of topology is that the availability of messages depend on the recipient peer being online at the same time as the sender. A simple solution is to keep a peer always connected. Please notice that this is not a server. It is just another peer running the same Keet client software. So when a sender goes online and broadcasts a message into a room, the relay peer picks it up and forwards it to the intended recipient as soon as it comes online. So this is the plan for today. In part 1, I will set up a Raspberry Pi with a Raspberry Pi operating system for uninterrupted operation. In part 2, I will install Keet and test it by communicating with a mobile peer. And in part 3, I will make the Raspberry Pi accessible from outside my local network, so I can manage it from any PC or mobile, without ever having to plug a computer screen nor a keyboard to it. This is going to be fun. Let's go. I need to flash the Raspberry Pi desktop operating system into a micro SD card. Go to raspberrypi.com. Software. You can either install the Raspberry Pi imager and follow the instructions, or download the operating system and do it yourself manually. I will do the latter. I will also copy the SHA-256 hash of the file to verify its authenticity. Everything is okay. I will use the Debian Disks utility to flash the image into the micro SD card. Restore disk image. Now insert the micro SD card into the Raspberry Pi, and turn it on. I am on a Raspberry Pi 4B. It is connected to my home router, and I have hooked a keyboard, a mouse, and a computer screen into it. The first thing you will notice is that there's something wrong with the mouse. It is sluggish, and the pointer can barely move across the screen. We'll fix that after we go through the initial setup of the OS. Click Next, and enter your language and time zone settings. Provide credentials for your administrative user. The mouse issue persists. So let's fix this first. Open a terminal window and edit the following file. Add this option at the end of its only line. Restart your system. Now that the mouse works properly, I can start configuring the OS for our purpose. First I'll upgrade. If you're not familiar with the Raspberry Pi operating system, this is your chance to mess around with its desktop environment. I will change a few things before rebooting again. Okay. So open a terminal window, and let's get on with the boring installs. You will probably have an SSH server pre-installed, but disabled by default. So enable it, and start it. I'll test it by accessing it from my regular computer, within my local network. This is the Raspberry Pi's IP address. SSH by password authentication works. Let's change it to public key authentication only. I will log out and move my public key into the Raspberry Pi. Now I will harden the SSH server. First by changing the default port for SSH. I will disallow password authentication and allow SSH connection requests only from my user, Keet. Now, the firewall. UFW does not come pre-installed. I will add a rule for allowing incoming SSH connections and enable it. Testing it. Great. Finally, I will install fail to ban to protect SSH from brute force attacks. Please make sure that the service is enabled. The following command will print a screen processes listening on specific ports. The SSH server listens on the expected port. But there's an additional process, lxsd, which by the way, schedules printing jobs, that I am not interested in. The following two commands will reliably kill it. I'll restart the system and check from the Raspberry Pi itself. I've finished preparing the Raspberry Pi. As a last step, please make sure that your Bluetooth is disabled, as well as your Wi-Fi. I will go to Keet.io, download the software, and check its digital signature. Everything is okay. So expand the tar file and delete everything you don't need. The Keet binary is executable, so execute it. Look in the upper right corner of the window. There's an update available. Update Keet by restarting the application. For our purposes, I need to be able to run and stop Keet remotely. So let's try doing this over SSH from my other computer. I will exit Keet. I will try starting Keet over an SSH connection. I get an error. For running programs with a graphical interface over an SSH session, you need to set the display variable as your remote host screen. Type the following command and try again. Let's see what is going on in the Raspberry Pi in real time. Now it works. Exit Keet by pressing Ctrl+C. We need a convenient way of managing Keet remotely. I want it to run on boot. I want to be able to restart it quickly, and I want it to be independent of any individual SSH connection. There's a few ways I could go about this, but I will use one of my all-time favorite tools in Linux, TMUX. Please check the description section below if you want to see me explain the basics of TMUX, in an excerpt from one of my videos. If this is the first time you've encountered it, you'll definitely want to watch that first, before continuing. TMUX is not installed on my system. Running Keet inside a TMUX session will allow me to keep it running independently of my SSH session. I can detach from the TMUX session, disconnect from the Raspberry Pi, SSH back in, attach to the TMUX session, and stop Keet. I will add 2 lines to my bashrc file so Keet runs on boot inside a TMUX session. First I will edit the display variable, and then I'll create a new, detached TMUX session, named Keet, with Keet running inside it. Let's test it by rebooting the system. And let's move to the Raspberry Pi. It works. Now I am going to create a few empty rooms that I can join from a Keet peer in my phone. By doing this beforehand, I won't need physical access to the Raspberry Pi every single time I need a separate room in the future. I will just use them up as I go along. I will create 3 rooms, but you can create 30 if you want. Bookmark all your rooms. Again, bookmark all your rooms. Let's test room 1. Now you only need your phone to invite other peers into your rooms. Click on the invite icon and share the link. Right. At this point, I will disconnect all the peripherals from my Raspberry Pi and make it truly headless. In this last section, I am going to make the Raspberry Pi accessible by SSH from outside my local network. If you don't know what a dynamic DNS server is, please watch the video linked in the description section below. There, I explain what they are for, and why we need to use one for our purpose here today. So I won't miss any step, but I won't explain much either. If you're confused, again, watch the video linked below. I am going to get an account at ddclient.io. A free dynamic DNS service provider. Provide an email. And select No. Log into your email. And follow the link to dsec. Check your email again. Follow the link to set your dsec account password. Your dsec account is ready. You can now log in. First, create a new domain for the Raspberry Pi, whatever subdomain you like, of the domain, ddclient.io. And second, issue a token. I advise you to save it next to your account password. Now I will SSH into the Raspberry Pi and install the dynamic DNS client, ddclient. I will set all this up manually. Edit the ddclient configuration file. Overwrite its contents. With this, linked in the description, I need to fill in my domain name and my authentication token. Restart ddclient. Make sure that the service is enabled. Okay. Listen to this. Although everything seems okay, take a look at ddclient logs. A warning. There's something wrong with the login field. I deliberately made this happen, because I've found that different versions of ddclient on different Linux distributions, do, or do not require, single quotes around the login field. This particular release of the Raspberry Pi OS, comes with a ddclient that, as you can see, does not require single quotes, So keep an open mind about this, and remember always to look at the logs when something doesn't work, or works unexpectedly. No errors. The server should already have an 8-type DNS record pointing to my home IP. Which of course I'm not going to show you. Okay. I will disconnect from the Raspberry Pi, and try accessing it from outside my local network. To do this, you need to make sure that your home router allows incoming connections to your SSH port. Let me explain. I've installed Keet on a Raspberry Pi, sitting behind my router, connected to the internet. During parts 1 and 2 of this video, I have been accessing the Raspberry Pi via SSH from a PC within my local network. The only reason I could manage this, once the firewall in the Raspberry Pi was up, is that I added a rule for allowing incoming traffic to my SSH port. If I want access from anywhere in the internet, I will have to configure my home router, so that incoming connections to my SSH port are also allowed. These are device-specific tweaks, so I can only guess at what you will have to do to your router. It usually boils down to 2 things. Make sure that your router's DHCP server always assigns the same IP to your machine, and ensure that incoming connections on your SSH port are allowed and forwarded to your IP. Once you figure this out, you will be able to SSH into your Raspberry Pi through its domain name. I can check if my TMUX session is running. I can update the system. I can stop Keet. And remember that by restarting Keet, you update it. Great! Now you can manage your computer from anywhere in the world. But what about mobile? My favorite SSH app in mobile is TermBot. It is open source, extremely simple, with a clean UI, and I can use authentication keys stored in a Yubikey for SSH, which is what I will do next. By the way, I have a whole series about Yubikeys where you can learn how to do this. So, in TermBot, add a new host. Type your SSH information, user, host, and port. I will be using an external Bluetooth keyboard, so you get a clearer view of the mobile screen. Unlocking the Yubikey. And now if you'll excuse me, I have to touch it. It doesn't have to be a Raspberry Pi. You can keep Appear running on any old second-hand laptop, and it will probably work even better. Have fun!